T10.11. Many people have asked the question, but few have been patient enough to collect the data. How many licks does it take to get to the center of a Tootsie Pop? After some intense research, a researcher revealed a 95% confidence interval for the mean number of licks to be 317.64 to 394.56 licks. All right. Now there's a footnote here, which means that somebody probably actually did this. I thought this was just like a joke kind of question, something that somebody made up. But if we looked at that footnote, it's probably real data. All right. Part A, interpret the confidence level. Okay, so the confidence level, right, to interpret it, you want to think about this picture here, right? So if we were to take many, many samples and create an interval for each one, then, some percentage of those intervals will capture the true value, right? Maybe it's 95%, maybe it's 90%. It just depends on what the confidence level is. Okay, so think of it as like the long run hit rate or the long run success rate for that confidence interval method. Okay, so back to our question here. Right, so this was a 95% confidence. Okay, so we'll say if many samples are taken and an interval created for each one, about 95% of the intervals will capture the true, and then here's where we're going to throw in the context, right? It's the true mean number of licks to get to the center of a Tootsie Pop. Okay. Part B, calculate the point estimate and margin of error used to construct the interval. All right, so I'm going to use that graphic, right? So this dot is the point estimate. That segment represents adding the margin of error. That segment represents subtracting the margin of error. Okay. So all we know are the endpoints, right? So the lower endpoint is 317.64, and the upper endpoint is 394.56. Okay. The point estimate is smack dab in the middle. So to figure out the point estimate, we could simply just average the two endpoints, right? If we find the average, that'll tell us what the middle is. Okay. I'm going to write down the work and I'm going to do the calculations off screen. Okay. So the point estimate is 317.64 plus 394.56, all divided by 2, right? We're just averaging. Okay. 317.64 plus 394.56 divided by 2, 356.1. Okay, that's the point estimate. Okay, the margin of error is the distance from the point estimate to either endpoint, right? So the margin of error is that distance there, or it's that distance there, right? So what we can do is we can take the total distance between the endpoints and divide by 2. Okay, let's do the work over here. So the margin of error is the total distance, 394.56 minus 317.64. That's the total distance between the endpoints, and then we're dividing by 2 because there's one margin of error that goes below the point estimate and one margin of error that goes above the point estimate. All right, just doing this off screen here. I think it's 38.46. Yep, that looks reasonable. All right, so that was part B. Sorry, the work is not very organized. A, B. Okay, part C. Name two things the researchers could do to decrease the margin of error. And discuss a drawback of each. Okay, so the margin of error is equal to a critical value times the standard error. Okay, in this case, the critical value would be a t-score, and the standard error would be like the sample standard deviation over root n. Okay. All right. So one way that we could decrease the margin of error is using a lower confidence, right? No, sorry. If we increase, no, that's right. If we decrease the confidence, that will lead to a smaller margin of error. Okay, so a lower confidence level would lead to a smaller margin of error. Okay, all right. That's because a smaller confidence level, right? Like let's just look at this row right here, right? The lower the confidence level, the smaller the critical value, and the smaller the critical value, then the smaller the margin of error. Okay, so that's one option. There is we could, option number one, decrease the confidence. Now, what's the drawback there is now we have less confidence in our statement, in our conclusion. You know, we want to be more confident, not less confident. All right, second thing we can do to decrease the margin of error is increase the sample size, right? By making, by making the sample size bigger, you're making the denominator bigger, which is then making the overall value smaller, and you get a smaller margin of error. Okay. So an increase in sample size will decrease the margin of error. Okay. Now the drawback to that is that, you know, it takes more time and potentially more money invested in the study to get a larger sample size.